Hello everyone, welcome back to SET-1 Part 2, wherein we'll be discussing 10 more questions from the TCS placement paper. These are all samples your questions which you can always expect in your upcoming exams. If you have not viewed the Part 1, wherein we have discussed 10 odd questions, go visit that. I'll attach the link in the description. Let's start with our question number 1 for Part 2, Set 1. The perimeter of an equilateral triangle. Perimeter, okay, so three sides, all these are equal, and the regular hexagon are equal, which means if you draw a regular hexagon, it would be simply like this. Now, a few pointers to keep in mind. All these sides are equal, and since it says that the perimeter or the outer boundary of the equilateral triangle is equal to the outer boundary of the regular hexagon, which means if I call this side to be A, and let's say I call these sides to be B, a simple relation is A is equal to 2B. I hope you are following this, because we have 3 parts here and here we have 6 parts. So 3 parts is equal to 6 parts. That can only be done when A is equal to 2B. That is our basic relation. Now, what we need to find out? We need to find the area ratio of their areas. So required ratio is area of triangle or equilateral triangle in this case is to area of regular hexagon. Let me put the formulas for both. So regular area of regular or equilateral triangle is given by root 3 upon 4 side square. Here the side is A, so I'll write A square. This is given by 3 root 3 upon 2 side square. Side here is B, so I'll write B square. Now in place of B, or let's say in place of A, can I write 2B? So this would be root 3 cancelled. Then we have this is cancelled as 2. And in place of A, I can write 2B. So this is 2B whole square upon 2. And this is 3B square. Okay, let me further simplify this quickly. This is 4B square upon 2. And this is 3B square. B square cancelled. This is simply 2:3 as our ratio. Now, we can take 3:2 as well, and since it is also given, now we have to be careful while marking. 3:2 cannot be taken as our answer because we have to start with whatever is given at the beginning or start of the question. It starts with an equilateral triangle, so you have to place it at the first part of the ratio, or the antecedent of the ratio or the first part of the ratio will be the area of the equilateral triangle, and the consequent will always be the area of the regular hexagon, what we have taken. So 2:3 is the correct fit and not 3:2. Please keep this in mind. I hope this helps. Take care. Moving on to the next question. What is the remainder of 32 to the power 31 to the power 301 when this value is divided by 9? We are looking out for the remainder. Now, these type of questions can always be simplified using the Euler's totient method. And how do we do that? We look at the base first. What is our base? Base is 32 in this case. So we can always reduce the base of a higher number into its lowest form by dividing it by the denominator and looking at the exact remainder in this case. So if I take 32 divided by 9, what is my remainder? It is 5. Now in this case, 32 can be broken down or simplified as 5. So 32 is no more 32, it is simply 5. And this is 9. And what do you have at the top? 31 to the power 301. Now, in order to break the power, we have to divide the same value or the power with the totient of the value. So the totient of the base is what? So the totient of 9 is 6. How do we get to it? All these methods you can always view our solution or the concept videos in which we have already explained what is a totient method and how do you go about finding the remainders. But I'll be going these a bit fast. So if you divide 31 by 6, you get the remainder as 1. So this becomes ideally 5 by 9. And since we have got the remainder as 1, so 31 is 1 to the power 301, which can be further written as 5 by 9, 1 to the power any value, we can write it as 1. So ultimately this is 5 upon 9. What is 5 upon 9? This whole value can be broken down as 5 upon 9. Now tell me quickly, what is the remainder? What do you see as the remainder? You see the remainder as 5, and that is my correct fit. I feel most of you won't be clear with how do we find the quotient of different numbers, how do we find the base, how do we break it down. All these things are a bit confusing, but if you follow the Euler's quotient method, these are not very difficult to tackle. That is what I'm going to say. You can always view our concept videos to have a better understanding of the remainder theorem. And with that, you can easily tackle these type of questions. I hope this helps. Which of the following numbers must be added? So which of the following numbers, let's say m, must be added to 5, 6, 7, 8 to give a remainder of 35 when divided by 460. So suppose I divide this whole set of number by 460. The remainder in this case must be equal to 35. That is what the question is all about. And what is m? M could be any of the 4 values, right? Okay. From here, can we say, upon dividing this by 460, the remainder is 35. So take out 35 from this value. So m plus 5, 6, 7, 8 minus the remainder, that is 35. Now this value, since we are taking out the remainder, the remaining part will always be a multiple of 460. It is completely divisible by 460. And since it's a multiple of 460, this value upon calculation must also end in a 0, because any multiple of 460, let's say 460 into 2 into 3 into 4, any value, any multiple of 460 will always end in a 0, the unit digit. So let's see, what do we have upon simplification. This can be further simplified as m plus 35 subtract, so we get 3, 4, 5, 6, 4, 3. And it must be in the form of a multiple of 460. So it should always end with a 0, the concept of 0 at the end. Now tell me, which of the values can you add to this value to get a 0? Since we have 3, the only possibility left is 7. Now do we have any of the values ending in 7? Yes. So we can be 100% sure that the value of m is 797. That is 797 plus 5643 is a multiple of 460. And that is what we were looking out for. With the help of option, upon a bit of calculation, we can easily tackle these questions. Suppose you would have got two answers, or two of the options would have been matching, then we would have to simply solve this and see whether it's a multiple of 460 or not. That is what we could have done. But here we have got our answer. I hope this makes sense and this is clear to every one of you. A girl entered a store and bought X flowers for Y dollars. Okay, so the cost price would be here simply of 1 would be Y upon X. When she was about to leave, the clerk said, if you buy 10 more, I'll give you all for $2 and you will save 80 cents in a dozen. Okay, So if the cost price of 1 is y upon 12, the cost price of 12 would be into 12, which is basically 12y upon x. Now the second scenario, upon buying 10 more, that is, now previously she was buying x number of flowers. Now she intends to buy 10 more. So in that case, what is our cost price again? So this should be, the number of flowers is x plus 10, and we are getting all of it for $2. So I'm writing 2 at the top. This is the cost price in the second scenario for one flower, and we intend to buy 12. So multiplied with 12, we get 12 into 2, 24 upon x plus 10, right? In the second case, if I buy 10 more, I actually pay lesser amount. I'm saving certain value. So which of the two cost price must be a higher value? This one. So according to the question, if I subtract cost price 1 minus cost price 2, I'm saving 80 cents, or 80 cents is basically 4 by 5 of a dollar. 80 is basically what? 80 by 100, which is 4 by 5. So that is what we have written. Now let's put the values. So we have 12y upon x minus 24x plus 10, and this is equivalent to 4 by 5. From the option, we can use any value and we can literally just solve this and check upon putting the values of x and y whether we are getting 4 by 5 or not. So I'll start with the simplest value, that is 5 and 1. So putting x as 5 and y as 1, let's see what do we have. And I'm only trying to solve the left hand side. 12 into 1 upon 5 minus 24 upon 5 plus 10. So I'm just trying to solve this part. It would be 12 by 5 minus 24 by 15. If I solve this further, 15, this is 36 minus 24, which is 12 upon 15, and upon simplification it is 4 upon 5. So LHS is equal to RHS, and these are the exact short values of x and y. Option C seems to fit in. You can always use the trial and error method of substituting values, and you can find out once we have an equation ready for us. I feel this part is clear to everyone. Let's move forward to the next question. If a number is divided by 357, in that case the remainder is equal to 5. Now my question is, upon dividing the same number by 17, what will be my remainder? And we have 4 options for the remainder. How do we approach these type of questions? Let me break down the question for you all. You are dividing this number by 357 and you are getting a remainder as 5. That means this number must be of the form 357x plus the remainder. And in place of x, you can put 1, you can put 2, you can put 3, you can put 4, you can put 5, and you can continue putting these values. So I'll start with the basic one, that is 1. So tell me, what is our number now? Number becomes 357 plus the remainder, that is 5. So it is basically 362. We have a number with us. We need to divide this number by 17. So we do that. 362 divided by 17. So tell me, I'm writing the quotient now. 17 2 times 34. Then you have 22. 17 1 times 17. And then you have the remainder as 5. So in the second case also I'm getting the remainder as 5. This is one way of doing it. ये एक तरीका है. You can use the other methods, or let's say the properties of remainder, to look at this question. What can you do? In order to do that, I hope ये वाला method सबको clear है, right? You can also put here x value as 2. So this would be double of this value plus the remainder, and you can check, you'd be getting the same result, no difference. For method 2, you can work on certain principles. The first one is, first you divide 357 by 17 and check the remainder. If you do that, 17 2 times is 34, then 1 time, so remainder is 0. Now upon getting the remainder as 0, the second step is, what is the remainder in the first case? Upon the divisor 2, that is 17. So it is 5 upon 17. Now tell me, what is our remainder? The remainder seems to be 5, and that is our answer. These are just different shortcuts to tackle a question. I've given you both the methods. You can follow whichever one is convenient for you. I hope this helps. In how many possible ways can you write 3240 as product of three positive integers a, b and c? For these type of questions, we always try to factorize this value and we look out for the prime factors. The easiest one is, since it's an even number, start with the even prime number, that is 2. So it is 1620. Next again by 2 it is 810. Again by 2 it is 405. Now with 3 we have 1, 35, 45, 15, 5, and then ultimately we have 1. Okay, so 3240 can be written as 2 cube, because you have 2 3 times, then 3 to the power 4 into 5 to the power 1. Now what is asked? As product of three positive integers a, b and c, and now we have these many values to choose from, so we'll use the formula for combination here. Let's see, what do we have? Once we try to select these values, then we'll look at the formula for permutation, and a combination of these two will give me the answer. Okay, starting with adjusting all the 2's here. So we have how many 2's? 3 2's plus 3 minus 1 upon c 3 minus 1. This way we select all the 2's. Okay, so upon simplification we would be getting this as 5c2, and 5c2 is simply 5 into 4 by 2 factorial. So this is 10 ways. Second, all the 3's. So how many 3's do we have? 4 3's plus 3 minus 1 upon c 3 minus 1. This is 6c2. 6c2 is basically 6 into 5 upon 2 factorial, which is 15 ways. Now the last one. 1 we have 1 time, so 1 plus 3 minus 1 c 3 minus 1. This is 3c2, which is 3 into 2 upon 2 factorial. These 2 and 2 goes out, we have 3 ways. Ultimate answer is 10 ways into 15 ways into 3 ways, which is 15 into 3 45 into 10 450 ways. Option A seems to be the correct fit. We have to be very good with our formula for permutation and combination in order to tackle questions like this in no time. I hope this helps. Take care. Bye-bye. On door A, it says it leads to freedom. On door B, it says it leads to green ghost house. On door C, it says door B leads to the ghost house. Now, these are typical questions from binary logic. It's a part of your reasoning segment. How do we start with these type of question? We start by writing down the different doors. Here we have A, B and C. And we look at all the possibilities. Okay. Now what is asked? Identify which door leads to freedom. So what we do, we tend to mark these as, let's say in the first possible scenario, door A is leading to freedom. That is certain. Now, based on this information, we'll try to look at what could be the value for B and C. In the second possible scenario, we are taking the freedom door to be the door B. And similarly, in the third possible scenario, we are taking door 3 or door C to be the door that leads to freedom. And based on these information, we'll try to evaluate each possibility and see what could be my possible answer here. That is how you should start a question on binary logic. Let's see, what do we have here? Okay. Starting with this. A leads to freedom. Okay, one more statement that is very important. The statement written on one of the doors is wrong. One of the doors is wrong, which means only one must be wrong. We have to be careful. That is, for 3 statements, 2 must be correct and 1 must be wrong. A leads to freedom. And it also says A leads to freedom. So this is correct. B says B leads to ghost house. And C says B leads to ghost house. So this is also correct. This is also correct. All 3 cannot be correct at the same time. Therefore, our assumption that A would be leading to freedom is totally wrong. Second. Now in this case, we are saying B leads to freedom. If we are saying that B leads to freedom, then this statement, it leads to ghost out, this is wrong. Now A leads to freedom, it cannot be. This is absolutely wrong. So we have got 2 wrong answers or 2 wrong statements. This cannot be the answer. Now let's start with the last possibility, in which we have assumed that door number C is leading to freedom. Now let's start with, what does it say? Door B leads to ghost house. Okay, door B is leading to ghost house. So statement, this is true. B leads to ghost house, that is also true. A leads to freedom, that is wrong. So how many ticks and how many wrong? 2 ticks and 1 wrong. This can be a possible scenario. So from here we can easily answer that door C with 100% surety will be leading to freedom. Option C seems to be the correct fit here. And that is how you look at a question on binary logic. I hope this is clear to everyone. In the given figure, if the sum of the values along each side is equal, then find the possible values of A, B, C, D, E and F, and these are in the order A, B, C, D, E, F. I hope this is clear. Now, for these type of question, it is always easier if you pick any 2 set. All of them are equal. So let me start by picking this one. That is, what is the sum of this values? 15 plus C plus D plus 5. This must be equal to 10 plus F plus 5. 10 plus F plus 5. So this 5 and this 5 is cancelled. What do we have? C plus D. 15 minus 10 plus C plus D. This is equal to F. Or we can call it, we have an equation as C plus D plus 5. This is equal to the value of F. We just need to check which of the option satisfies this equation. What are the values of C and D and F respectively? C is this value, D is this value, and F is the last one. So if we start with option A, I'm writing A, that means I'm talking about option A. What are the values of C and D? 20 plus 16, that is 36 plus 5. 36 plus 5 is 41 and F is 38, not matched. So option A cannot be the answer. Let's start with B. 10 plus 13, 23 plus 5 is 28, and here we have 38 again. This does not match our answer. Next one. 20 plus 13, 33 plus 5 is 38, and right hand side F value, that is also 38. So this matches. So this will be my answer. But let me just check the last one. real quick. 20 plus 16 plus 5. 20 plus 16 is 36 plus 5 is 41, and here f value seems to be 33, so it is not matching. All three are eliminated. Option C will give you the exact values of A, B, C, D, E and F, and that is how we can use this to answer these type of questions. Always. Also, we could have started by picking these two as well. It depends, or we could have picked these two sets. Pick any two, try to form an equation like we have formed here, and then use the option to get to the correct answer. Alright? Okay, moving on. Missing number series question. What is the next term in the given sequence? And the sequence is 70, 54, 45, 41, and then the next number. So always start by taking out the common difference or the difference between two terms. Here it is 16. The difference here seems to be 9. The difference here is easy. It is 4. What could be the next difference? Do we have a connection here? If you look closely, this is 4 square. This is 3 square. This is 2 square. So we have a connection here, decreasing in the order of squares. So next one could be 1 square, which is 1. So 41 minus 1 is 40. Option D seems to be the correct fit. Most of the questions of your number series is based on the application or the deviation from the original square series or the cube series. To have a better understanding of the number series, look out for the logical reasoning segment or the playlist Logical Reasoning for All Competitive Exam under my channel. I have covered this in depth. Have a look to understand this topic more clearly. How many positive integers less than 500 can be formed using the numbers 1, 2, 3 and 5 for digits, and each digit being used only once? That is, repetition of digit is not allowed. How many positive integers? So we can look at 1-digit number, we can look at 2-digit numbers, we can look at 3-digit numbers. Alright. Now, how many 1-digit numbers are possible? So we have 1, 2, 3, 4. So 4 ways or 4 numbers are possible. Next, how many 2-digit numbers? So any of the two places can be filled in 4 ways. Any of the next place can be filled in 3 ways. So the answer is 4 into 3, which is 12 numbers. Next, please be careful here. For 3-digit number, can we have a number as 5, 1, 2 using these digits? Yes or no? Just think. No. Or 5, 3, 2 or 5, 1, 2 or 5, 1, 3. We can't, because the numbers must be less than 500. So if I put here 5 and if I put any of the other digits here, it will always give me a value which is greater than 500, which may give me a constraint, that is 5 cannot be placed at this position, but 5 can be placed here or here. So in order to fill the first spot, how many options do I have originally? I have only 3 options. So this can be done in 3 ways. One option is used out of the 4 options. Now 5 can come here or any of the 2 options, which gives it 3 ways and 2 ways for the last case. So this is actually 3 into 3 into 2, which is 18 numbers in total. Alright. These are 3 different cases. So cases are always added up at the end. So 18 plus 12 plus 4 is 34 numbers in total are possible, which are less than 500 using the set of option, that is 1, 2, 3 and 5. 34. Option D seems to be the correct fit here. I hope this helps. For more such videos, you can watch our playlist on TCS, wherein this was part 2. इससे पहले हमने पार्ट 1 भी कवर कर रखा है. So watch that as well as other competitive exams. You can also have a view. Take care. Bye bye. See you all in the next video.